In the previous simple program study, we used the mnemonic instructions like load that are easy for humans to understand, but that is not what computer understands. So we need to translate that kind of mnemonic instructions that computer can understand. That is called the assembler. So in the previous example program was like this. We showed using mnemonic English word like load, add, store, halt. So as a human, it's very easy to understand, but that's not what computer can actually understand. Computer need this kind of binary ones. So from here to there, you need a translation. That translation is called the assembler, and the assembler is a software that does the work. So assembler and compiler is different. The compiler is for high level language like C++ or Java, but assembler is a lower level one. The assembler, there is a one-to-one correspondence. So as we have a load, as we have a store, there's a one-to-one correspondence between mnemonic instruction and machine code. But high-level language is not true. In high-level language, we have a if, while, and the like, but there's no one-to-one correspondence though. So as you run the assembler, it translates the mnemonic source code into object program file to create that object program file. That is what computer can understand. It actually does two passes. In the first pass, the assembler assembles the program as much as possible, but mainly it builds a symbol table, and then in second pass it completely translates all of those mnemonic code into machine language. So let me explain that in detail. So here is the example we used in the previous lesson. So that is a load, add, store, halt. Then in this, we introduce a few more things. First, in addition to write instruction load add, so before that we could have some word and then comma. So that is called the label. The purpose of the label is to get the address at that location. So what it does is X, comma, and the DEC means decimal. So at this location, decimal 35 is stored in the computer memory, in the marie1 computer memory. And then Y, comma means at that location, decimal negative 23. And then Z, comma, hexa means hexadecimal 0 is stored there. So suppose we give this example program beginning at address 100. At address 100, we have a load X, and then 101 add Y, store Z, and then halt. Then after halt, we have X, comma, decimal 35, then counting address from 100. At this moment, X label X is at address 104. So for label X, address is 104. This is called the symbol table. So symbol table is first created in the first pass of the translation. So starting from beginning address, just count where the address X label is used, and then Y is used at address 105, Z is 106. Then using those symbols, now the instruction is translated. So load is in OP code, first 4 bits of the instruction. OP code is 1. Add is OP code 3. Store is OP code 2. Halt is OP code 7. So load X means OP code 1, and then label X. Add Y is 3Y. Store Z is 2Z, halt is 7, the rest is all 0. So we have another symbol table, which is a translation of the instruction using symbols. So those symbol tables are created. That's the first pass of assembler. And then on second pass, Now using those symbol table, the entire programming is translated into machine code. So the previous it was a 1 and x, but x is a 104, so x gets a 104, and then 3y, y is a 105, and then 2z, z is a 106, and the 70 is a halt. Then on next location at address x is 104, 23, decimal 35 is hexadecimal 23, decimal negative 23 is hexadecimal FFE9, hexadecimal 0 is 0. So we have finally get the assembled code, the object program code is there. So that is the second pass of the assembler.